Hello, I'm Carl Douglas, a founder of DI Labs. Thanks for watching this today. So the live stream is something that we put on. It's really unique in our industry where we're giving a behind the scenes glimpse into our business and how we produce products. It's something that I've never seen from any other company that's like us, and we've done that because we're really product developers at our core. We're engineers. And as we've developed products in the past and leveraged prototyping services, we've never really had an understanding of how products were made and what the process looks like. So it was always a curiosity of ours. And knowing that we're serving you, folks like us, we figured that it's kind of valuable. And if nothing else, it just fulfills a curiosity to know what goes on behind the scenes at a rapid prototyping or 3D printing company. So here we are. And we're about to share our journey with you in this expanded facility that we're in. And there have been some things that we've removed. All of our customer projects that are proprietary have been removed from our work area to protect their confidentiality. And some of our own proprietary processes we've pulled out of view. But outside of those things, the rest of our area is essentially open and transparent for view. And it's our way of sharing with you how we operate behind the scenes, and as you're working with us and send us projects for fulfillment, this gives you an idea of what those projects may go through as they're being produced. So thanks for watching. It's about 60 minutes, and there's some questions and answers at the end, and as you have other questions and answers, feel free to reach out to us. We're happy to address those. Thanks so much, and enjoy.
Welcome to DI Labs. Thank you for joining us this morning and having the opportunity to walk through our facility. Today we have Carl, Sean, and myself. Carl's going to walk you through the different areas that we currently have, and I'll be showing you some case studies of projects that we've accomplished.
Before we get started, Sean can't see his whole face. He's wearing a 3D printed mask, and we jokingly call him Darth Vader. It's obvious why. But we'll see Sean again as we get through the production area.
So, thank the product developers, engineers, entrepreneurs, business owners. Thank you all for joining us, and competitors. Thank you for being here with us, and hope you enjoy our facility.
See you guys in a bit.
See you soon.
Thank you. So we'll take a quick walk through the space as we get to the manufacturing area. And we'll start here with a line drawing map to show the space that we have. And it's kind of important from a workflow standpoint. Most of our projects start in the area that we're in here now, which is our engineering and design area. And at our foundation, we're in engineering. It just so happens that we operate several different additive manufacturing technologies, but we're not a typical service bureau, so to speak, because we are product developers. So most of our projects start in the engineering and design area, and then as they have review and final analysis and get approved for production, they'll go back to what we jokingly call the Magic Factory, where we turn basically digital files into physical realities. So we'll get into the Magic Factory. We'll talk a little bit about our post-processing area, then move into the Multi-Jet Fusion print room, which is a dedicated room. And then we'll take a tour over to our advanced finishing technologies. And as we're taking this journey, Brian's going to be in our Innovation Center sharing case studies. So we're in the pre and post-processing area. And this is mostly dedicated to our powder technology, which is the Multi-Jet Fusion. And you can see that we've got basically four stations, four processing stations. Each of these stations is dedicated to a particular material. We have polyurethane. So that allows us to produce parts that are flexible in nature. It's a material that HP just launched within the last several months. And it's been something that we've been evaluating to be able to serve our customers. So this is where the process starts, essentially. We'll have build units that will share in the other room. Those build units will be loaded with a blend of reclaimed and fresh powder. And then they'll go into the printer room where they're loaded into the printers. And we'll go into that room. Right out of the gate, you see that room is separate from this, and that's really intentional. So one of the things that we've learned through the process is how important it is to have thermal and humidity control for the area that the printing is done in. So we've isolated our print room here to be able to finally control the temperature and the humidity, which is really critical for the tolerances and the dimensional accuracy of parts. And we'll talk a little bit more about that as we go into the room. So as you can see on the right side of the room, we've got several Multi-Jet Fusion machines. They're all the same, and they can run any of the materials that we have available in our processing centers. They are all running, and the way that these are set up is it allows us to switch over from a nylon 12 job to a TPU job right away, just like that. And it's because the material is not housed in the machine, it's housed in the build carts. So at any one point in time, we can have dozens or hundreds or even thousands of parts in a particular build. Those parts may be for a specific project or for a multitude of projects that are all combined together. And what we'll do is we'll design each of those builds to make sure that the pack is optimized for the particular project, for things like tolerance or dimensional accuracy or aesthetics or strength. So we'll mix and match parts that are of like nature to be able to optimize those characteristics that are most important for that type of job. So we've got this example part here that Brian's going to talk a little bit more about, which is an example of a bridge production application that we've run using the Multi-Jet Fusion. Brian, go ahead.
So this product, and it's pre-tooling. This particular part is a high tolerance, high quality control part where we have to verify our tolerances on our threaded fittings, because this turns into a part of a product that is watertight for pressurized water. And controlling those tolerances, as Carl mentioned with packing builds, it's really critical for us to manage through pilot tests and through product testing the orientation, how tightly we can pack those parts, how much gap we need to leave between them. Going through this build pack allows us to fine-tune those tolerances and deliver upon customers' expectations. For in a job like this, the customer is waiting for tooling. There's a 5 or 6 week lead time where they don't have parts in hand. And we were able to get them parts in a matter of a week, allow them to start assembly and then continue down their path of product release. So, Carl, this was an example of a high tolerance, high quality part. Could you give us an example of a high volume, low tolerance part that we've worked on?
Sure. So, like Brian was talking about, that was a high tolerance or high precision, high accuracy part. And one of the images that Brian showed on the screen was a virtual pack of the parts. So that virtual pack that Brian was showing on the screen is one of our, essentially a virtual representation of one of our build units. So that's the machine that houses the fresh powder and then the final parts. That's essentially where they sit in that gray cart. And we've got several of those carts, and there's many reasons for that. Here's another interesting application, that these small baskets are an iterative design project where we were developing a hydroponic solution for produce. A customer came to us and wanted to be able to develop a certified organic produce in a hydroponic application. So they brought us this problem, and then we started doing a design for that particular application. But the challenge is, when you're going through a design, especially in something like agriculture, where you need to do a lot of testing, it's really tough to get that design optimized if you go straight to injection molding. So what we did over a series of about 10 weeks is we did real live testing in their greenhouse to be able to optimize the design. Over that 10-week period, we produced something like 15,000 of these baskets. And each of the builds had about 2,000 baskets in it. So not only were we designing the part for its function, but we were also designing it for manufacturing to make sure that we have to meet his demand for that period of time that he needed the demand. All in total, we produced about 30,000 of these baskets using the multi-jet fusion, and that allowed him significant gains that we hadn't expected in the beginning from a crop yield standpoint and optimizing those crops, because we were able to iterate several times through the design and learn from the results and live testing. So it's almost like taking more of a software iterative design approach to hardware or products that it's almost impossible to do with injection molding, because they're so tooling locked once you get that tool manufactured. So in those types of scenarios, we'll run new builds a product like this to be able to increase the daily output using our 4 machines. And as you can see, as well on this other side of the room, there's a bunch of space where we're planning on adding more machines here in the near future. And that's just to meet production needs. But here's another kind of a unique project. So this was a panel that was printed for a specific application. It's a long, slender panel. For those that are familiar with injection molding or other molding applications, the thermal control of molded parts or plastic parts as they're cooling is really important to ensure that you're maintaining the warp, minimizing warp, maintaining dimensional control. So this is a project where we produced hundreds of these thin wall panels for a specific project. And that's where, again, many build units came into play. And more importantly, having the build units in this controlled environment allows us to cool them at a very controlled rate. And that's the magic behind producing dimensionally sensitive parts and producing them with high precision. So Brian, if you wouldn't mind sharing with us the result of this project and where we applied this panel, that'd be great.
So the cooling properties and how we manage that, maintaining our tolerances over that cooling process, is highly critical, and especially in the case of this project. Working in the validation stage, prep before tooling. This project is a full-scale fuselage. Our client came to us and needed a near-net shape product where ergonomic testing and where ergonomics can be tested and where the look and feel of the product can be tested. In this case, by 4.5-foot diameter fuselage. And the way we control that cooling is by managing the pack of that build and ensuring that we have very long cooling times and the right cooling times so that these panels don't warp. And what that nets us is that nets us a full-scale fuselage where we can hide the seams of the panels with our proprietary joining method. And in this case, there's some solutions where we can still deliver this product with a paneled look. But in cases where we need to have a look, a feel, and a product that doesn't look as though it's 3D printed, we'll go through our paint shop and we'll finish this with an automotive finish in a gloss, matte, or any color that our clients are looking for. And our result is a very clean and presentable product. So, Carl, we just went over the finish and look of the aircraft. Can you share with us the full color and what that means and what we can do with that here?
Thanks, Brian. So, thinking about that fuselage and the fact that it was multiple parts that were joined together, developed the joining technology, and then more importantly, developed the finish process. Finishing is really important to 3D printed parts. That's like the secret of the industry. As we talk about scaling production and production type applications with 3D printing, the thing that many people don't talk about is the finish that comes out of the printers, in most often cases, isn't optimized for production type applications. So for those that signed up for the sample parts and got the bottle openers, you got 3, and one of them is a gray bottle opener. So that gray bottle opener, it came out of our, we call the monochrome printers, so Multi-Jet Fusion and gray, and that's how they come out of the machine, after being depowdered, of course. And then you have another bottle opener that's red. So the example of red is another post-processing activity that we do where we'll color the parts. And we can color them a multitude of different colors, but again, it's all monochrome. So those are 2 examples of parts that come out of the monochrome Multi-Jet Fusion. But in a lot of cases, monochrome isn't good enough. So you have another bottle opener that's full color. And that came out of the same type of technology, it's Multi-Jet Fusion, but it came out of the full color machine. So it's made from nylon 12, some engineering grade material with mechanical properties that are similar to injection molding. But in this case, it's full color. And for those that are in the group, they're a little bit nerdy and kind of like me, like engineering stuff. What we did here for fun is that we did a simple FEA analysis of our bottle opener so that we can demonstrate the stresses that are on this part, this tool, when it's being used to open a bottle. So it's not just a pretty map on there, it's actually functional, and it shows the high and low stress areas of the bottle opener. And when we're relaxing a little bit after a day's worth of work, we get to visualize the stress on the bottle opener as we lower our stress after we open a bottle of liquid. So that's the full color. And the other thing about this bottle opener is that it didn't just come out of the machine. So this was chemically smoothed, chemically processed to be able to surface and seal the part. And Brian's got another couple of applications where he's going to talk a little bit more about this and show it close up.
So, thank you, Carl. The advanced finishing that we've been focused on here at DI Labs and bringing in technologies that allow us to finish these additive parts so that they're now an end-use product. It's been our focus, advanced finishing. In this case, we have a tap handle. This tap handle is a full color part and it's been surface finished. It allows us to have a sealed surface that's sanitizable, it's cleanable, and it's intended for end-use product. The challenging part of full color parts is their tendency to bleed or not maintain their color when unsealed. which gives them limited use and limited access into different markets. But having this fully sealed part allows us to supply and support that end-use need when we need information for lettering on jigs and fixtures, if we need full-colored hands feeling, part in hands tactile finish, and other solutions that we want more color than just a gray or dyed part. So this is a great example of our advanced finishing. Carl is going to take us in and show us the machines that we have. Carl, do you have a few more examples there?
Yeah, sure do, Brian. Thanks. So this is a new machine that was just added within the last couple of weeks. And it's the chemical processing machine that finished the stress bottle openers that everyone has. And so basically the process works as though the bottle opener is printed, it comes out, gets depowdered, and then it goes into the chemical processing station where it then gets chemically smoothed. And that's really important, like Brian was saying, really important for parts where they need to have the aesthetic appeal and value of an injection molded part and not look as though they were 3D printed. For parts that are going into automotive applications or aerospace cabins or other consumer products, often carries a negative connotation. It's nice to have the customization, but that it just feels and seems cheap. So putting products in the place where they can have that same aesthetic value as molded parts is really critical. And even things as fine as this model that was printed on the color machine to help companies market their products. This is a scale model of a mechanical process machine. This allows us to print it and then finish it with really delicate parts to, one, enrich the colors, and then two, allow people to pick it up and handle it and then have it be sanitized and cleaned without worry of it getting stained. So there are several of these types of applications where we'll leverage these types of technologies together, the printing and the post-processing, to be able to provide production level parts for low volume applications. And another example is a medical device application where you want to be able to print a housing or a handle for a particular assembly and be able to include the branding and the directions printed right onto the part. Those are things that we're doing today and having biocompatible product that can be used in the operating room. So from here, we'll move into our adjacent room. And as it turns out, we've got a couple of different pieces of chemical processing technology. We've got another machine here that also uses a solvent chemical, but it works in a little different process. So what we found is we're serving our customers' needs. They'll bring us a particular problem, and if we don't have the solution for that problem in-house, or we can't develop it, then we invest in it. And we do so to be able to solve those needs. And in some cases, we have some technologies that are similar. They may have overlapping capabilities, but in many cases, the overlap is small, and then the breadth of coverage outside of that is quite wide. So we'll use each piece of technology for particular applications where those needs are required. And as it turns out, we're the only company that has both of these types of chemical finishing equipment. We're the first to bring on the Dimension VFS machine, and we're the only company to have both. And we really appreciate the opportunity to be able to work with those different technologies and be able to provide unique solutions. So now we'll transition to another machine. Hey, I didn't know you were going to be in here. How you doing, Alex?
Hi, Carl.
Good seeing you here.
Nice to see you.
So this machine was just installed again in the last couple of weeks, and it's the Carbon DLS machine, and it's probably most famously known by the Adidas 4D shoes. So these are Adidas shoes that you can buy from Adidas, and the midsoles on these shoes were 3D printed.
They've been making them for years, and they're mass produced. And the uniqueness about this technology is the Carbon enables us to print with about 18 new materials that we don't have access to with our other technologies. Everything from elastomers to rigid materials to really high temp capable materials. And in this case, the midsole in this shoe was 3D printed with an elastomeric polyurethane. And it allows the shoe to exhibit a level of comfort and rebound that you can't get with a molded midsole. And so you can see that and you can see this on Adidas's website, there's a specific lattice structure that's designed into this shoe. And this is an area where 3D printing allows us to manipulate the material response by reconfiguring the structure. Things that you can't do with subtractive or molding type manufacturing methods can be done with additive. So while in a technology like this, we can only print with a single material at the same time, we can manipulate the design to have a mechanical response as though we were printing with multiple materials. So it's really changes the paradigm of how to think about design from a product development standpoint. And a lot of this technology is really manifested itself and been launched in the last half a dozen years or so. So it's fairly new technology. From a product development standpoint, we leverage all of the technology that we've got in-house for our customers on our own product development projects. And it allows us significant competitive advantage over where we would be if we didn't have access to this technology. So we'll just take a quick glance over here in the corner. We won't spend a whole lot of time, but this is another piece of equipment that allows us to do metal printing and stainless steel and Inconel and tool steel and copper. And it's just another way where we have a lot of different printers and materials that enable us to bring those materials together as a complementary solution to provide really unique results for. So Brian, if you wouldn't mind sharing a little bit more about how this all ties together in a real application.
Thanks, Carl, for walking through those different workflow processes. And as we think about our other capabilities at DI Labs, we have the multi-jet fusion, and of course we have the Carbon and MetalX. We have a series of other printers that allow us to produce parts from PEEK and Ultim to basic PLA and carbon fiber reinforced nylon 6. And beyond that is really our focus on new product development. We are new product developers. And it's about taking the ideas and bringing those products to life in a thoughtful way, whether we're incorporating additive manufacturing, injection molding, blow molding, CNC machining. Those are all manufacturing processes that we're familiar with. So as we help our clients come up with the right solution, a lot of times those become additive solutions, but they can also become sheet metal and other products as well. So we like to think of ourselves as a full product service where we can design nearly any product and support our clients in those ways. In this particular case, a client needed a solution for downstream operations in their manufacturing plant, going through trials of 3D printing and producing this tool, which cuts off corrugated plastic pipe, and transitioning to a sheet metal tool down the line where we delivered that to all of the plants. So this is another example of our strengths as not just additive designers, but product designers in general, and providing all of those solutions.
Thanks, Brian. That was a really nice rundown. We're not wearing masks because it's too hard to talk and hear us with masks, so I'm wearing this shield. And I know that you don't have COVID, but I'm just going to be safe. So all joking aside, we're all facing with this, what everybody calls the new normal through the pandemic. And we've all heard in the news about how additive manufacturing has helped solve critical problems and bring health and safety back into our society where we have to face this unexpected challenge of the virus. So we had a local customer that came to us that has several manufacturing facilities all across the region, and they were faced with the same challenge. They basically said, look, we've got thousands of employees. We need them to continue to work because the work that they do is critical, but we can't find any facial protective gear, PPE, that serves the needs of our manufacturing plant and satisfies the weight requirements and safety and ergonomics for our safety department. Can you guys help us? So this came to us one day, and they said, basically, we've got to have hard hats, we've got to have ear protection, and we've got to have a lightweight solution that doesn't negatively impact the workflow of our team members. Come up with something. So within a period of several days, and there's one behind you here on the shelf, over a period of several days, we went through several different iterations using multi-jet fusion for prototyping as well as some carbon fiber printing to come up with the design basically that you see here. We've produced thousands and thousands of these frames. So the part that we've printed is the part that Brian's holding, and it installs on the hard hat and interacts with the ear protection, and then has a mounting location for the shields. So we developed many iterations of this and ended up going into full production. And what we discovered and managed through in this project, it wasn't just about the product development, it was also about the design for additive manufacturing.
And our client had very stringent requirements to make sure that we were satisfying the needs of the operators. And in this case, we needed to have ample airflow in front of the operator's face to prevent any fogging and allow for plenty of airflow for the operator to breathe. It needed to be, and it also needed to be manufactured at a quantity and a price that was reasonable for the quantities that they're working with. So over the course of a couple iterations and pilot production and going into full production, we delivered this product, got the solution in their hands, and made sure that we met all of their requirements from dropping, breaking, fatigue, and today they're in use and continue to order this product.
So the neat thing about that is that they had some off-the-shelf products in use in their plants, and they found that this was designed and functioned so much better than what was already in place that they got rid of everything else. And just another example of where additive manufacturing can help change the game in situations where an urgent response is needed. This is pretty dramatic, and it doesn't have to be that dramatic, but additive manufacturing can provide solutions in cases where there's no other method that can be as responsive to a specific need. And if you were thinking about this in terms of a product, getting it to the market, in a case like, right now we're in COVID, but if it was in a different scenario and you've got competitors, it can mean the difference between having a successful product line and not having anything at all by being able to leverage additive. If you have any questions, feel free to contact me. My information's below. And email and phone's fine. And we'll be available to answer questions and look forward to talking to you and interacting with you, serving your needs.
Thank you so much for your time, and we look forward to working with you.
Thanks so much.